like, oh, there we go. 3x squared times 2x to the fourth. This is kind of a review of what we did before. You know, you're going to multiply the coefficients, 6, and then you have variables, the same variable to different powers. We're just going to add the powers. So we have 6 to the 6th. But what if I had 3x squared to the third? So we're going to multiply the exponents. What's the exponent on the 3? A 1. So you're going to multiply those together, which is 3, or 3 to the third. Gives us 27. X squared to the third, you said was x to the 6th. Why is that the case? Why do we multiply the exponents? You know the rule. Do you know why it's true? Well, what does this third power do? It's saying how many times you're going to multiply by itself. So if we have x squared 3 times, then we just convert it back into this type of problem, where we add the exponents together. So x squared to the third means 3 versions of x squared. If we count up all the x's, there are 6. So here you see the third power in the fact that there are 3 squareds. So this says x squared to the third, 3 versions of x squared, which gives me x to the 6th. So if we go on to something a little bit harder, 4x squared times 2x to the negative 5. Same type of problem. We multiply the coefficients. 4 times 2 is 8. It's going to be x. And whenever we have the same variable to different exponents, we add them. So I end up with x to the negative 3. What does that mean? Have you ever seen a negative exponent before? I see some head bobbles. I'll ask my wife. Do you know what the car keys are? Okay. I don't know what that means. Well, let's look at a different problem. What if we had x squared over x to the 5th? What is that going to be? Okay, well, in this problem over here, we're multiplying, and we're adding the exponents. If we move on to division, it only makes sense that we subtract them. So now the terrible question, why do we subtract them? Yeah. Well, does anybody know what the answer to this is? 1 over x to the third. So I subtracted. Why did it land in the denominator and not the numerator? Could I have written, so if you subtract this way, then you get 1 over x to the third. What if you subtract the other way? You get x to the negative 3 over 1, which we don't need to write that 1. And they're actually both correct. One of them is not preferred, but they're both true. Okay? Why are we subtracting? I'll give you the secret. As soon as I write it down, you're going to see it. Why do we subtract? All we're doing is canceling the common x's. So what is x over x? 1. So we just create a 1 from those two x's. X over x is 1. So the 2 on top cancel 2 of those on bottom. And we subtract. We had 5 to begin with in the denominator, and if we subtract them, we knock 2 of them out, and we end up with x to the third. So if I had x squared times x to the fourth, those are on the same side of the fraction, and they work together to create x to the 6th. But if they're on opposite sides of the fraction, then they sort of fight each other out, and whoever's bigger ends up winning. So these are equivalent, but this one is preferred. We don't like to leave negative exponents. So whenever you have a negative exponent, you just switch it to the other side of the fraction and make the exponent positive. So if we did something like 4/6a squared b to the negative 3c to the 5th, a to the negative 4, b to the negative 2, c to the 8th. How would we simplify this? Let me do the hard part for you. 2/3. 4/6 simplifies to be 2/3. What am I going to do with my a? Well, what do I do with a negative exponent? Flip it to the other side and change it to a positive. So this jumps up on top, and I have a to the 4th. Now, are those two a's going to work together or against each other? They're now working together, so we add them and get a to the 6th. What about the b's? They're both going to flip. Good. So this one comes down, and it's b to the 3rd, and this one moves up, and it's b squared. Are they going to work together, or are they going to fight it out? And which one is the winning side? The bottom is bigger, so it wins. The two b's on top knock out 2 of the 3 on the bottom, so I have b in the denominator. Is this making sense? Okay. Do I need to move any of the c's? Nope, they're all positive, so we can just cancel like we normally would. 5 on top, 8 on bottom, so we have c to the 3rd in the denominator. Okay. Let's make it a little bit harder. What should we do first? There are actually lots of ways to figure this one out. Some are faster than others. So move those negatives, or do the squared on the outside. Okay. So 2 to the 2nd is 4. 6 to the 2nd is 36. What is a squared to the 2nd? A to the 4th. Good. B to the negative 3 to the 2nd. B to the negative 6. A to the 10th. And b to the negative 14. Okay. Oh, wait. Oh, that's right. 4/36 is 1/9. Now, I could write a 1 up there, but I only need it if everything else disappears. So I'm not going to write that 1 yet, but I might need it here in a little bit. How many a's am I going to end up with? 6 in what position? On the bottom. So, oops, a to the 6th. B's. They're both going to switch. So this one becomes a 6, and this one becomes a 14, and when they fight it out, the top wins. B to the 8th. Okay. Do you see another way to work this out? No? Let me show you one. Go ahead, Nathan. You can. Yep, because it's a single term, you can always work inside those parentheses first. So, 2/6 is 1/3. A squared over a to the 5th is a to the third in the bottom. Then I'm going to move the 7 up, and I'm going to move the 3 down. So I'd have b to the fourth on top, and now I can square that. And you'll get the exact same answer. B to the fourth to the second is b to the eighth. 3 squared is 9. A to the third squared is a to the sixth, and I have the same answer. So sometimes that's actually faster to simplify what's on the inside first and then bring the exponent in. One more that you need to see. 36, say 24ths, a to the negative 4, b to the third, a to the 7, b to... The only difference here is the outside exponent is a negative. Okay? And there are a couple different ways to deal with this. Let's simplify the inside. What is a common factor between 36 and 24? 6 goes into both of them. Anything bigger? 12 goes into both of them. Let's divide them by 12. 3 halves. How many a's am I going to end up with? Well, these 4 are going to come down. I'm going to add 4 to 7. So a to the 11th. B squared on top. This 6 moves up and becomes positive, and this 2 moves down and becomes positive. Then when they fight it out, we have more on top than we do on bottom. C to the fourth. Now what about that negative 3? Here's one way that works, but I wouldn't recommend it. You could go through and multiply this into all the exponents. What is that going to do to those exponents? It's going to make them all negative, and if you write them down, then you're going to have to flip it and rewrite it. Okay? So we automatically know all of these land on top, and all of those are going to land on bottom. And then we just take them to the third power. So 3 to the third is 27. Where do I want to write that? On the bottom, because everything's going to flip now. So 27, b squared to the third is b to the sixth. C to the fourth to the third is c to the 12th. 2 to the third is 8. A to the 11th to the third is a to the 33rd. Now, what if I weren't to simplify this down all the way? What if I would have divided by 6 and I would have got 6 over 4 and then I took it to the third power? Is that going to create a problem? What if I simplify correctly but I don't simplify all the way to the end? I would have ended up with 36 over 16. No, yeah, that's well, and then I need to switch it. So it's 16 over 36. Is that the same thing? Oh, third power. Oops, I messed it up. Sorry. Ignore that. 216 over 64, which actually is exactly the same thing as that once you flip it upside down. So even if you make a mistake in simplifying, you should notice that mistake later on when you get finished. But if you simplify all the way to the end, then the answer will not need to be simplified. Okay. You have 2 worksheets to work on, and you have answers to those worksheets. So get to work.